Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Iman bin Abdul Manaf and my matric card number is TH23015. So we are from group 4 and our title for this project is gas flow through a 19-degree elbow, and the basic principle engineering dynamic we apply for this project is impulse and momentum. First, I want to present about the abstract. Abstract for this project is the study applies a steady flow momentum analysis to evaluate force on a 90-degree gas by elbow. Impulse momentum principles are used to explain and transient force during rapid flow change. Flow directions change produce a significant force on the elbow. Result confirm that velocity and direction change generate high reaction force requiring adequate pipe support and vibration control. So next we go to the introduction and backgrounds. First, I will explain about background of this project. In the oil and gas industry, pipelines carry natural gas between processing units. Pipe bands or elbows are used to change the flow direction due to the plant layout. A 90-degree elbow is commonly used in a complex facility. When gas flow at a high speed through the elbow, the change in the flow direction causes a force on the elbow and its support. Next, we go to the problem statement. Gas velocity may stay constant, but a 90-degree elbow causes a change in the flow direction. This change creates a momentum force acting on the elbow. If not properly designed, this force can cause vibration, fatigue, and a structure failure. Therefore, it is important to calculate the force and understand the effects of the sudden flow change. Okay, next we go to the next slide, which is the objective. So for objective for this project is to model gas flow through a 90-degree elbow using impulse and momentum principle to determine the force acting on the elbow under steady flow condition, to analyze the effect of transient flow change using impulse and momentum concept, and the last is to evaluate safety and support design implication and propose method to reduce dynamic loading. Next, we go to the next slide, which is a system description and assumptions. So for the system description, the system consists of a pipeline carrying natural gas that change direction through a 90-degree elbow. Gas enter the elbow horizontal and exit vertical. The elbow is rigidly supported by a pipe support. A control volume is defined around the elbow, including the gas flowing through it. The inlet and outlet cross-sectional area are assumed to be the same. So a schematic diagram show horizontal inlet part and vertical outlet part, 90-degree elbow, and inlet velocity which is V1 and outlet velocity which is V2, and the control volume around the elbow.
Assalamualaikum, my name is Muhammad Syamuddin bin Zaidun. I will present about system description and assumptions. To the idealization and assumptions is to simplify the analysis. The following assumptions are made. First, flow is steady during the steady state analysis. Second, gas density is constant. Third, inlet and outlet velocities have the same magnitude. Fourth, flow is uniform across the pipe cross section. Fifth, frictional losses and gravity effects are neglected. And lastly, the elbow is rigid and does not deform. Next, theory or basic equations applies the impulse and momentum principle to analyze the forces generated when natural gas flows through a 90-degree pipe elbow. Momentum or steady flow, gas changes direction, change in momentum, force on elbow. Linear momentum equation, force equal to mass multiplies by V out minus V in. This equation is suitable because the gas experiences a change in momentum as it flows through the elbow. The elbow experiences force in both directions, which are important for designing pipe support and preventing vibration or structural failure. Impulse momentum or transient flow, sudden velocity change, large short-term forces. The equation is force differential T equal to mass multiplied by V2 minus V1. Shorter delta T, higher impulsive vibration and fatigue risk. This principle explains why sudden flow changes are more dangerous than steady flow.
Next, for my part, I will explain the methodology and calculation used to analyze the force acting on the 90-degree pipe elbow. So, the analysis is based on impulse and linear momentum principle, and it is divided into steady flow and transient flow analysis. First, for the methodology, we define the known parameters for the system. The gas density was taken as 0.7 kg per cubic meter and the pipe inner diameter as 0.3 meters, and the gas velocity was assumed to change direction by 90 degrees as it passes through the elbow. Next, we calculated the mass flow rate using the equation where this mass flow rate is essential because it directly affects the momentum change. After that, the linear momentum equation was applied separately in the x direction and y direction, since the gas enter horizontally and exit vertically. So at the inlet, the gas only has velocity in the x direction, while for y direction it's equals to 0, while at the outlet the gas only has velocity in y direction, so for x direction it's equal to 0. This allows us to calculate the horizontal force Fx and vertical force Fy acting on the elbow. Finally, the resultant force acting on the elbow was obtained using vector addition of Fx and Fy. For transient flow, such as sudden valve opening, the impulse momentum equation was used. This analysis showed that when the same momentum change occurs over the shorter time, the force acting on the elbow becomes much larger. Now for the result and discussion. From the table, we can see that as the gas velocity increases, the resultant force acting on the elbow increases rapidly. For example, at low velocities, the force is very small, but higher velocities it increases to over 100 newtons. This happened because higher velocity results in larger momentum change, which directly increase the force acting on the elbow. The result also showed that transient flow condition generates much higher force than steady flow. This means sudden flow change are more dangerous than normal operating conditions. For the graph, the impulse versus time graph show us a clear linear relationships confirming that impulse increasing proportionally with time. This proves that time duration plays a key role in controlling how severe the force is. Additionally, the elbow experiences both horizontal and vertical force, which means pipe supports must be designed to withstand multi-directional loading, not just a single direction. If these forces are not properly considered, sudden flow change can cause vibration, fatigue at weld joints, and long-term structural damage.
For conclusion, the change in gas direction at the 90 degrees elbow can create a constant force that acts on the x and y axis, requiring the system to handle a multi-directional stress. The impulse vs time graph show that the impulse is directly proportional to the time interval, which is delta t. The highest risk occur during the transient step that can create a peak force that can lead to the vibration, fatigue damage, and structural failure of the pipe support. So we can conclude that the proper support design and control operation are essential for safe and reliable pipeline system. Okay, next is practical recommendation. Okay, first is implement gradual valve actuation. Okay, valve, we should know that valve should be open and closed slowly to protect the system. So by controlling the time interval, the kick or impulse force is spread out. So this will prevent the sudden shock that can cause the damage on the elbow. Next is installing the vibration damper. Okay, for the high velocity gas line, adding the damper or flexible support can absorb energy from momentum fluctuation and reducing the risk of fatigue cracking in the pipe well.